Okay, so this is what we call the miscellaneous unit, mainly because it's kind of a compilation of just like a lot of things going on with different kinds of lessons. And one of those is referring to something called scatterplots. Now, this is really an 8th grade lesson that feeds into algebra in a little ways, but the main part of 8th grade is knowing the vocabulary behind it. So scatterplots, if you notice the graphs themselves, are just a random assortment of an arrangement of data plots on a graph. And the really comes from the definition scatterplots. But a scatter plot is just a graph cluster of dots, which represents two variables, x and y. So just technically one word. But what we take it, so let's go over the 3 types that we see. So the first type is, think of slope in a way, the direction of the line. We know that the dots themselves are going upwards, so this is called a positive association. And what makes it a positive association is that as x increases, so does the y. And then if we look at this next one, notice the direction of the dots are decreasing, going down. So this is called negative association. And that happens when x increases and y decreases, or vice versa, when x decreases and y increases. And then we have the last one, which if you notice the dots themselves are not in any direction whatsoever. And this is known as no association, because it's just no direction whatsoever. So there's that. Now, what we do in algebra is take this a step further. So naming it is just as important, but we talk about something called correlation coefficient. And what that means is we're trying to determine how strong of a relationship a linear scatter plot has, or nonlinear. But with that, we talk about a scale. So strength goes there. So when I'm looking at the scale, and we'll talk about where that number comes from, but when I'm looking at a scale, I'm first determining if it's positive or negative. So if it's a positive number, we're going to look on the positive side. If it's negative, we look on the negative. The closer the negative is to 0, or between 0 and 0.5, it's called a weak negative. That means it looks more or less like this graph, but they're a little bit more spread out, but I can still tell where the line's going. Versus if it's anywhere between negative 0.5 and negative 1, that's called a strong negative. And that just means that the dots are tighter together. Versus the other side of positive association is if it's 0 to positive 0.5, that's a weak positive. That means it's going the direction of positive, but the dots are a little more scattered, but I can still tell where they're going. Versus strong positive is between 0.5 and 1, and that's whenever it's positive direction and the dots are closer together, almost in a straight line, okay? But let's talk about what that means. Okay, so I'm just going to jump to the back of the notes. What you have to do, so if you notice, think about a table, what we've done in the past. Anytime you're given a table, we're going to use stat. That's our go-to. But before we use stat, we have to turn on what's called our diagnostic. Lots of ways to get there, but the quickest way is you click second. Hold on, let me see. It's been a while since we've done this, since last year. Make sure I do it right. I know there was a quicker way last year, and it's not coming to me. Oh, there it is. So what you have to do to turn on your stat diagnostic, I apologize, is go to mode. So next to second is the mode button, and we're going to scroll upwards. And notice that towards the bottom it says stat diagnostic. We need to turn that on. So you go up until where you see flashing on off, and you go to the right and to hit enter to turn it on. Like, that's literally it. So then whenever I type these into stat, okay, you have to type the entire table into stat. So my X's go on the left. And then my Y's go on the right. And just be careful, because the more there are, the more likely we are to make a mistake when we type them in. And then just like we did with linear regression back in chapter 3, you do stat calc 1 or stat calc 4, sorry. And we're going to see what kind of linear relationship this is. So we're trying to find the line of best fit. And notice you do get crazy decimals that look like this. But notice, but in the past, we've only seen A and B. Today, we're going to talk about R here at the bottom. But let's talk about the equation. So we're going to round to the hundredths place. The more accurate your decimal is, the better off you're going to be. So if I round to the hundredths place, the slope is negative 1.06. And normally we would change that to a fraction, but not for this case. And then since the y-intercept is positive, we put plus 92.31. And again, I always go to the hundredths place for more accuracy. But notice the other piece of information on the calculator is the r value, r squared and r. Next semester we'll talk about r squared, but r is referring to the linear correlation. So if I look at the number itself, it's negative 0.97 if we round to the hundredths place. If you remember our scale that we talked about earlier, it's a negative, so it's going to be on the negative side. And negative 0.97 is closer to negative 1. So that's going to be referred to as a strong negative. And that's it. That's the classification, strong negative. Now then, we're going to take it a step further and use our equation to determine, we're going to estimate the average temperature of a city with a latitude of 25. Well, if we look back at our table, latitude was referring to x. So what I'm going to do with my equation is I'm going to replace x with the 25 to make a prediction of what the temperature would be in that case. So then this part, I honestly just use my home screen and I type in what I wrote, replacing x with with the 25. And then let the calculator do the mess of a math problem there. And so we can estimate that the temperature at that latitude is going to be 65.81. Now, if I completely lost you, let's do that again, okay? Now, my tip for you would be don't reset your calculator like we normally would, only because I would have to go back and turn my mode diagnostic on again, over and over again. Versus if I just want to avoid that, then I'm just going to go back to stat, edit, and then just to show you how to clear this, you just hit delete, 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 delete until you get rid of all the y values, and then delete, 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 delete to get rid of all the x's. So I didn't show you all that in chapter 3 for that reason, but here it is. Now, the hardest it gets on these tables is when there's years involved. If I know that 1980 is the first year, we are going to label that as 0. And then we look at the pattern of years. From 1980 to 1984, 4 years went by, so this is 4. From 1980 to 1988, this is 8. From 1980 to 1992, that is 12. And from 1980 to 1994, that's 14. From 1980 to 1998, that is 18. And so when it comes to years on the table, you have to adjust them to meet single values. So don't leave them like 1,980. Otherwise, you'll get the wrong answer every time. So instead of using the years, we're going to use 0, 4, 8, 12, 14, and 18 as my x's. And then 422, oops, too many 2s. 432, 404, 420, 395, 382. And then like we did on number 1, we're going to do stat calc 4. And you get a crazy looking number, but you're going to see some this crazy because we're looking for the line of best fit. Because if I graphed these points, they wouldn't make a perfect line. And so the line of best fit is more or less just figuring out what line meets the middle of all of those dots. Again, we're going to round to the hundredths place. So it's going to be negative 2.29x with a y-intercept of positive 430.56. Then we look at the R value, my correlation coefficient, and it has a negative correlation of 0.81. If I look at that scale, remember, it's closer on the negative side, and it's between negative 0.5 and negative 1. So we would call that a strong negative. Now, again, we take that one step further, and now we want to make a prediction of the time it would take in a 2012 Olympics. Well, here's where I have to think a little bit. 2012 is how many years from 1980? That would be 32 years. So I'm plugging in 32 in for x instead of 2012. So that's the hardest part about it, is you have to think about substitution. And so then I'm going to type that into my home screen. I don't know where that came from. And then my estimation is in 2012 Olympics, it would take them 357.28 seconds on the 500 meter dash. Let's do this again. So again, anytime years are involved, you don't want to type in 1,980. We're going to assume that 1980 is the first year, so 0. 1980 to 1985 is 5. 1980 to 1990 is 10. 1980 to 1994 is 14. 15, 16, 17, 18. And then those are the values we're going to type in. Now remember, instead of resetting my calculator, We're just going to delete each value under L2. Okay, and then we're just going to type in 0, 5, 10, 14, 15, 16, 17, 18. And then the Y values would be 86, 126, 166, 217, 231, 245, 261, and 279. And then we do stat calc 4. And again, you're going to get some ridiculous looking numbers, but the line of best fit through those points would be a slope of 10.60x and a y-intercept of positive 75.48. Now the correlation coefficient this time, notice, is positive, and if we round to the hundredths place is 0.99. Since it's on the scale closer to positive 1, we would call it a strong positive, a really strong positive. And then if we were to predict in 2008, so think about this. If this was 2008, how far away is 2008 from 1980? That would be 28 years. So in the equation, you're going to replace x with 28, not 2008. And then you're going to type it into your home screen and get an answer. So I can make a prediction that in the year 2008, the sales for this particular store is going to be $372.28 billion. Now then, let's take that into consideration for this. What if you're not given a table and you're given a graph? Well, it's like making your own table. So I'm going to work from left to right looking at these dots, and I'm going to find all the X's first, and then I'm going to find all the Y's. Now we could spend the time writing that down, but all you really have to do is type them in as you see them. Sorry. Okay, so the first dot here is at 0. The second dot is at 1. The third dot is 2. Fourth dot is 3. Fifth dot is 4. And then 5. Then my Y values, again, starting from the lowest to the highest, is 16.5, 17, 17.5, 19, 20, and 20.5. And then we do stat calc 4. Okay, and then again we get a line of best fit, so the slope would be 0.87x with the y-intercept of positive 16.24 if I round. My R value is 0.98, which, if we remember that scale, is closer to the strong side of positive, so strong positive. And if I want to predict how much you would spend on books in 2005, keep in mind that right here it mentions that 1990 is the 0 value. So from 1990 to 2005, that would be 15 years, which is what I would plug in for X to solve for how much a book sales would cost, or what the book sales would be. And it would be roughly $29.29 dollars. Okay, so relatively easy. Again, anytime you're talking about correlation coefficient, you need to turn on your stack diagnostic by going to mode and scrolling upwards to turn it on. And you only have to do that once if you don't reset your calculator.